Composing gloves here, and today we're going to go over the basics of Kicad and schematic creation. We're also going to go over some simulation tools that are just pretty handy to know about and use so that when you're testing circuits. This is intended for my students that I teach at Citrus College. So if you're not one of those, if you're like a regular YouTube viewer, this will seem a little strange. It's a super fundamental basics introduction class. Let's dive right into it. And if you're curious, by the way, on my website, the labs are publicly available. So if you want to go through them, if you got any feedback, I'm always listening. And let's go for this. So first up, look up Kicad on Google. So this is Kicad. It's a free computer-aided design software, and we're going to use it to make our schematics. That's what CAD stands for. We're going to go to download and pick your operating system. I'm going to go with Windows, and then these are the downloads. Either one's fine. Go to GitHub, and it will just automatically start downloading. I don't need to download it. I've already got it, so I can just leave it off. And once you have it on your system and it's downloaded, go ahead and make a folder. So open up a new folder. I'm using Windows key E to do that, but you can click on the taskbar, the little window icon, the folder icon. And in Documents, I recommend you make a Kicad Projects folder, which is somewhere in here, right here. So I have one. This is where I put all my Kicad projects. And I recently had a computer wipe, so there's not much in here right now. But there are, this is where we're going to put them. So go ahead and make that folder. Now go ahead and boot up Kicad. So find Kicad on your machine and open it. And it's going to open. I'm not sure if it'll prompt you to make something or not. But we're going to go to File, New Project. And we're going to make sure you're in your projects folder, wherever you put that on your computer. And give it a name. So I'm going to go ahead and give it the name of, new project or whatever. A terrible name. You'd call it like Lab 1 or something. Let's call it like Lab 1. We'll hit save. And if we actually go to that folder really quick and look at it in here, I'm just going to sort of skip over to there. So here's our folder. If we go to it, we notice a Lab 1 folder is being created. And in here, we have a PCB. We're not going to use this file. It's just generated for us. The actual project file, this is what you'll double click to open the project if you close it and come back. And the schematic file. And if you double click this will actually open up the schematic editor. But I always double click this and then click it through here because that's how I'm used to doing it. So we are interested in the schematic editor itself. So we'll click that. It opens it up. And if we had a schematic, it would be here. But for now, it's blank. So to navigate, and I'm assuming you've got a mouse and keyboard, don't do this with working this with a touch, a trackpad on a laptop is very annoying. At least on my laptop, these zoom controls and everything are all weird and funky. So I heavily recommend just using a mouse with a mouse wheel to do this. So you could scroll with your mouse wheel to zoom into where your mouse is at. I use this all the time. It's awesome. Middle click mouse wheel will move your screen around, and right click mouse wheel will do, or just right click. Right click will do the same. To move left or right, hold Control and scroll your mouse wheel. You could also just move this down here. You'll never see me come down here. There's just better ways to move. And shift scroll mouse wheel will move you up down. So that's navigation. You're going to get real good at it because you'll be moving around a ton. So to place components, go over to the Add Component icon. It's right over here. It'll load up your components. And there are several, some of which we have not yet talked about based on when you're watching this video, because you're probably on Lab 1. But there are several that we'll need to know. If you look up Resistor, you'll find a bunch of different ones. And we'll have potentiometers and all these different ones. What we are going to use is the US resistor. So you're going to type R_US. And this will bring up the US resistor, and we'll go ahead and double click it, or you can hit OK. I'm going to zoom in. And to rotate components, you can hit R. To flip components horizontally, you can hit X. And to flip components vertically, you can hit Y. So those are all the ways to place components. So I'm going to go ahead and place down a resistor. And we're still on the Add Components tool because we still have that little triangle down there next to our cursor. So if we click, it'll bring the dialog back up. And let's grab a battery. The battery we will be using is a battery cell. And this is what it looks like. This is a DC voltage source. So we're going to hit OK and place that. And there will be schematics where we will have 2 batteries. There will be some where we just have 1. Most of the beginner circuits will just have one. Another voltage source you may want to be familiar with is if you actually just look up 5 volts, this indicates that this terminal, if we put it like this and connect it to something, this is the same thing as connecting to 5 volts. Now, of course, we're dealing mostly with 9 volts. I don't know if they have a symbol for it. Yeah, they do. So we could go ahead and connect it to 9 volts. And if we hit escape, we'll leave the add components tool. And if you double click, you can change the values. So you see here, we have the value that we can edit. But for some reason, this does not want me to edit it. I know with the batteries we can. So we could come in here and we can give the battery a value. This is the name of the battery. This is the value of the battery. So we'll give it like 9 volts. There you go. These might be specific references, so we might not be able to change these. So we'll probably also want minus 9 volts. And this one we'll typically want to rotate. So we'll see these components here in action here in a second. We'll get rid of this one. Yeah, so to select components, you can just click drag, or you can just click on them. And if you hold control, you can add more components to your selection, like so. Clicking to add, I think you have to hold shift. No, I'm not sure why it doesn't work like that. But if you click drag and then you hold control while you're doing this, it'll continue to add components. If I were to just drag without holding control, every click makes a new selection. Okay, a few other components we need to know about. We need to know about the polarized resistor and just the regular, not the polarized resistor. That makes no sense. The polarized capacitor. So if you type cap, we will get, or just C, you'll get a regular old unpolarized capacitor. But a lot of the times we'll want a polarized one. So here it is. You can see which side has the plus. And mostly you just need to know how to interpret this. But if you ever need to add one, this is the symbol. And we will also need a op amp. So the op amp we will be using in class is not actually, doesn't have a standard symbol in here, but a TL072 is got the same pinouts. So we're going to use that. So TL072, this is it. And now it's a little chip with 8 pins. So when we click to add this, we'll add the first 3 pins, the next 3 pins, which is a separate op amp, and the power pins. So this expects a positive voltage source and a negative voltage source. So for these things, we can just click drag to move them. We would connect them like this. And this would be the same thing as connecting it to our battery. You're going to see schematics in which we have 2 batteries connected. So for example, let me show you real quick. Oops, let's not get rid of everything. Let's say that we don't have these because we're going to want to show it with how our batteries are connected. So we'll have our battery here. So this, we'll call this middle section 0. And we'll copy this battery and paste it. And we'll flip it horizontally so that the 2 negatives are right here. So we will define this to be 0 volts. So we could put a ground. That's going to be a symbol that we're going to want. So to do that, we will come over here. And this ground is going to be a signal ground. I know we don't talk about the types of grounds, but just so you know, this is a ground. So if you type in ground, GND, we'll be given, and it's the very first one. So this is a signal ground. It just means that we're going to use this spot as 0 volts. And to go over to the wire tool, you can click on the end of a component and add it, or you can just hit W. And if you hit W, you can create wires like so. So we get rid of those, Control Z, and I'm just going to add it. A dot means things are connected. A brief comment about wires. So let's say that this is like a wire. If we have a wire go like this, these wires are not connected. If, however, our wires go like this, these wires are connected. I see students sometimes try to do what we kind of do sometimes when we're handwriting, and we'll do this sort of a thing. And like the little up and over. This just is confusing and messy, and it's just harder to do in Kicad. So just stick with the dot convention. This convention is easy, well understood, and we'll stick to just one convention. When you're handwriting, usually it's pretty obvious, but I highly recommend just using the dot. It's clear. Don't be doing stuff like this. It's just going to be a little bit messier. It's harder to do anyways, and it's less clear. Okay, so here we go. We've got like, so this would be like our ground, and then this would be like our positive voltage. So we would attach this up. And by the way, let's say that I want to keep the wire up here. I can click and it will fix the wire in that spot so that no longer does it move up and down. Because before, if I clicked and I moved down, you see how the wire sort of, let's say I want it up here, but then I move down, it shrinks. Let's say I don't want that. I can click and now it stays there. Just so we have a nice clear node a little bit of ways away. And like this. So this is the same thing as our battery being connected to the positive chip. And this is pin 8, the positive voltage source for pin 8. And then pin 4, we get the negative voltage source. So you're going to see this in the corner of some schematics that you'll be making. And this is exactly what it is. But we can see here ground, the batteries, how to connect things up, like pretty nice. And so this would mean that, on the chip, pins 5, 6, and 7 are connected some way, pins 1, 2, 3. So as you get to those, we'll talk more in depth about what these mean. But in Kicad, that's how you add them. And again, we'll be using the TL072 as the component, but the actual component we'll be using is the OPA 2134 because it's the dual version of it. Let me make sure I've got the right name. Yeah, the 2134. So we could just rename it to the OPA 2134. And, that's how we can do it because the pinouts are the same. So we'll have OPA 2134 and that'll be fine. Now there are question marks next to everything. And this just indicates that the things have not yet been numbered. They have not been assigned a value. So if you come up to tools and you go to annotation, which is right here, annotate schematic. And then you just hit annotate. And what it'll do is it'll number them all. So now they're numbered. And if we were to do simulations in here, we would need to do this. And there's a couple other reasons why. But for the most part, I'm going to get rid of these because we're just looking at how to create the schematic. So let's say that you made a schematic. Let's just make a basic one real quick. Let's get rid of this bottom battery and these things and this wire here. And that wire. And let's just create real quick a basic thing. So I'm on the mouse move tool. Oh, let's get rid of these two. Okay, in this. Let's just say we're dealing with just a basic resistor. I'll come up and let's just say I've got some more of these. So I'll rotate this and I've got another one. So we'll paste that in and I want the thing on the bottom. So I'll hit, it's not going to let me. We can move the text separately. We can grab it. Click off and we can move just the text. And let's connect these all via wires. And you know what? Just to show you parallel, let's just put one over here and we'll have this one set up in parallel. Like so. Okay, so let's say that this is our circuit. And we technically do not need to deliberately notate a ground, but we'll put a ground here just so it's extra clear. This is where we're going to say ground is at, but this is just a reference. Remember, this circuit will work whether or not we have this ground symbol defined. Now, simulation-wise, I think it requires you to have a ground, but in reality, this is just a point we agree is 0. So with these, you notice these aren't annotated. So let's go ahead and let's go into tools, annotate, and annotate them. And now these are the values, these guys right here. So let's call it 1K. And we'll make the K lowercase. So this is a 1K resistor, and we'll copy this value and paste it. Oh, we can't do that. That's a bummer. If we had copied and pasted the resistor like this, it would keep the value. But unfortunately, we didn't do that. 1K and 1K. So there we go. We've got our resistors. If we want this one to be 2K, we could do that, 200K or whatever. And boom, we have it. So now how do we take this out of the program and get this out? To export this schematic as an image, there are a few ways to do it. The easiest way to do is to just use your built-in screenshot tool. So on Windows, you can hit Control or was it Alt? No, it's Windows key Shift S, and it will bring up the tool to just draw over an area. It'll make it as a screenshot, and you can edit it and save it and do whatever you want in here. And place it in your lab report. Just go ahead and, copy it or whatever. And you can just go straight to your lab report and hit Control V and it'll pop up there. Another thing you could do is you could use Greenshot, which is what I use. It is this guy right here. So it is a free software. If we pull up here and we just look up Greenshot, this is the logo. We go down here, go to downloads, and you can download it for it. Now, this is for Windows. I'm unsure if there's a Mac version. Mac has their own way of doing things. So if you're on Mac, you'll have to figure that out. But take a screenshot or one of those things. If you want to use Kicad to do this, you can go up to File, Export, or not Export, File, Plot. And then in Plot, choose SVG. So with SVG, you could choose Plot Current Page. And we can go ahead and then go to the project folder that this is in. So we'll go over here to our project folder. And we can see in here, we have an SVG that has been created. Now, this SVG is going to be huge. It's going to be the size of the entire page. So if we open this up here, zoom out, it's going to be really big, and this will not work for the lab because this is just too big. Your circuit will look really tiny. So let me show you this program I'm using. So if you go to, oh, I think I closed the page. We'll go new incognito. So if we look up Inkscape, Inkscape is a free way, it's a free software. And we'll go ahead, click this and download it. And once you're in Inkscape, go ahead and open up this file. And you can right click on it and say open with, and then choose Inkscape. If it's not in here, you'll have to say choose another app, and then you'll have to go looking for it. Or you could open Inkscape and then open this. I have it by default so that when I say open with, I can say choose another app, and then you can say always use this app to open SVGs. And then I'd have to go searching for Inkscape. And if you need to, you have to go to your program files and like find it. It's this pain kind of a thing. But once it's set up, you're good to go. So go ahead, double click it here. It'll open up. Now select the stuff you're interested in. And with this stuff selected, go to File, Document Properties. It'll open up this window. And then in this window, choose Resize Page to Content. And then just click the Resize Page to Drawing or Selection. So it's important things are selected, so it knows to do this. However, I noticed here I've missed R1. So let me do another selection here. And resize. For some reason, it's not selecting R1. I'm holding down Control and Shift. And I'm adding these selections. So if you hold down Control, Shift, and click, you can add to your selection. I don't know why it wasn't just automatically selecting it. But now we'll do it, and we see that the border is perfect. And all we have to do is hit Control S, and it will save this new document. I always do it a few times just because I'm paranoid. Okay, so now just to show you, if we open up with something else like Microsoft Edge. Now it looks tiny here, but let's go to a, let's open up a Word doc, or if you're using Google Docs or whatever, we'll open up a blank document and we'll drag this in. And there it is. We can zoom this up and it'll look great. It'll look fantastic, right? Because it's an SVG, and SVGs, you don't want to do a PNG. Do an SVG. SVGs, well, when they zoom up, they'll look super crisp because it's using math basically to draw all the lines and shapes. So it's really nice. So anyways, that's the first way. The other way, which again, I think this way is like much faster and easier. And if I'm just looking to do things quickly, Control Shift S, go ahead, you got it. And then we can paste it in here. Now this one's a PNG. Looks identical though, since we're not going to be doing zooming, so it's going to be fine. If you were to zoom this up though, things will start to get pixelated when you start getting really big. But it's not going to be an issue for what we're doing, especially if you're zoomed in. Like you zoom in so it's a good size. It gives you more resolution. And then finally, if you use Greenshot to do it, you can hit just the print screen, which is, if we just go to Greenshot, which is right here, we can go to Capture Region, and it'll let you drag a region, and then we can save it, save as. And this will have us save it as a file somewhere. So we'll call it like, our file, and then, you know, keep note of where this is going and save it, and it will open it up. And so here we have our file inside of our folder. And if we wanted to, we could go to Windows and then drag this on, and it will likewise add it. So there's a bunch of ways to add it. There's really no good excuse to not have a decent picture in here. Make it look nice, make it good. That's Kicad in a nutshell. That's mostly what you're going to be doing. Now, there are a couple other softwares, and the screenshot tools will be handy there. And again, if you're on Mac, you're going to have to figure out how to do the screenshots on Mac. And you might have to crop them or whatever. Yeah, that brings up a good point. If you are in here, you can actually right-click and crop, and you can crop them however you want. So if they are big or whatever, you can adjust it inside of Windows to make them bigger or smaller. I like the SVG method. I think it looks the best. Okay, so that's the first one. There is another piece of software called, I never say it right, it's like Fritzing or something. We will go to new incognito window. Fritzing. And this is it. So this is Fritzing. So go ahead and open it. If you decide to use this, you go over to the breadboard tab and you have your components. Now the components here are a lot more limited, but this is also a simulator. So for example, we could have, here's a resistor. We could add a battery to it. Let's grab a battery from the voltage sources. We'll grab a battery here and we'll come down here in the corner and change it to a 9 volt. We'll connect it up. So we'll make this our positive and this our negative. There we go. And let's move the resistor over here just so everything's over near each other. We'll link up the resistor to positive, and we can recolor the wires to like red or whatever. And we'll put an LED through this. So we'll look for an LED really quick. There's an LED somewhere on here. Where are you at? Right here, LED. And this one, we will, I can't remember how you flip these. It's either like Control Y or X or something. Let's go to, oh, maybe there isn't one. Flip. There we go. So now we've got our anode, and then we'll hook up our cathode to go to negative, and we'll change this wire color to black so it's clear that it's going back. And now we can hit simulate down here at the bottom, and we can see, did I wire this up wrong? No, this should be fine. This is fine. This is fine. Oh, it's complaining. Okay, so that's a cloud of smoke. It's complaining that this value is not high enough. So what is our resistance here? Our resistor is at 220. Let's just bump it up to, let's just do 1,000. We'll do a 1K resistor. And there we go. It's turning on. We could change it down to a 500 ohm resistor. I don't know if it shows the different brightness. Can it show different brightness levels? We'll change this to 500. Oh, there we go. Oh, so it does show. So that was dim before because the 1K didn't let through enough current. So there you go. That is how you can, simulate. But what's kind of nice here too is there's a schematic, and it generates the schematic. Now the schematic looks like a hot mess, and you do have to draw on the wires. So let's rotate this like so. We'll rotate this like so, and we'll bring this over, and then we can draw on our wires. Yeah, it looks pretty nice. And I don't use this one regularly, so I mostly use it to just get pictures and show things quickly. But there you go. It's, labeled more or less, and you're able to go through and create a schematic this way if you so desire. And this one also has the ability to simulate it. Now, the downside is I believe this is not capable of handling the more complex things that we're going to do. We'll see when we get there. So that's Fritzing. Kind of cool. Another tool that's worth knowing is, and I always have to look it up because it's something weird. If we go to the JS circuit And oh, there it is. Falstad JS circuit simulator. It's this thing. So this is the site. I'll probably add links and stuff to this down the line. You can add circuits in here and move them. Now, moving around, these components are not the most straightforward to move around, and the attachments aren't. So I'm mostly just putting this here as a reference. I use embeds on my website to show this. I like how visual it is. I like its interaction. But just so you know, this is another tool. You could take a screenshot of this, and I would be okay with that as well. That's totally fine. And then finally, the last one is Tinkercad, which is up here. Tinkercad's not loading. Sometimes it's slow to load, which is why I have the pictures as a backup. So we'll go to Tinkercad. Now you'll want to log in or sign up and use a personal account. If you're a student, do not say you're a student unless, because we don't have like a school thing. I'm just doing this because I think it's a neat resource. So yeah, just say use personal account and then like sign in with your Gmail or whatever. Okay, so once you're in, you could create new designs. Obviously we want circuit designs. So I've already got some here, but we could click the new and then do circuit and it'll open up. And then these again are embedded in my site. See if they load. It's kind of like a toss up whether or not they load sometimes, which is not a good look, but whatever. There it goes. And then you can actually just click on Tinkercad to go to tinker with the designs if they're public, which they usually are. And again, let's just go to one I've already got. So we'll just click on simulate. And we could also click on tinker this, and it will bring us to the actual editor. You can drag things in and edit them, and you can hit start simulation and it'll actually begin to run. It's complaining about the resistor value. And we can actually go into a schematic view right here, and you can see it creates a schematic. Now, this is something I'm not sure if we're able to edit or change this, but it's there. It actually creates a bill of materials too, which is pretty nice. I don't know if you're able to move this around though, which is kind of a bummer. But again, you can take a screenshot of this, and it's just another tool. One thing I didn't talk about that I also forgot to mention, we will need in Kicad also the ability to add a potentiometer. So if you type in potentiometer, here we go. We have one style potentiometer. We want the US one, and it shows the pins. And just like all the other components, you can flip it X. This is the one we're flipping it across Y will probably be pretty handy, and knowing how to rotate and move around X. And you can double click on the value and change it to, whatever you want, like a 10K. And we have here our potentiometer. But anyways, that's how you could do this. That's how you can make schematics. Hopefully I've answered all your questions. If you have any other questions, feel free to drop them down in the comments. I'll address them, and maybe I'll make another version of this video that is even more complete. With that, thanks for watching and have a blessed day.